Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Building Applications with AWS Lambda. Building applications with AWS Lambda brings a paradigm shift to how developers approach serverless architecture. AWS Lambda enables developers to run code without provisioning or managing servers, offering automatic scaling, high availability, and a pay-per-use billing model. This approach effectively removes the traditional constraints of server-based computing, paving the way for innovative solutions and significant cost savings. AWS Lambda functions, also known as Lambdas, are the basic units of deployment and execution in AWS Lambda. Each function is essentially a piece of code written in one of the supported languages, such as Python, Java, Node.js, or Go. The code executes in response to events, which can be anything from an HTTP request via Amazon API Gateway to changes in an S3 bucket or updates in a DynamoDB table. The event-driven model allows developers to create highly responsive applications that react to changes in real time. One of the critical advantages of using AWS Lambda is its scalability. Traditional server-based applications require developers to estimate the maximum load and provision servers accordingly, often leading to over-provisioning and underutilization of resources. AWS Lambda automatically scales the number of function instances based on incoming traffic, ensuring that the application can handle any load without manual intervention. This scalability is underpinned by the AWS Lambda execution environment, which isolates each function invocation, providing consistent performance regardless of the workload. Cost efficiency is another significant benefit of AWS Lambda. Traditional server-based applications incur costs even when the servers are idle, leading to wasted resources and higher expenses. AWS Lambda follows a pay-per-use model where costs are incurred only when the code is executed. This model can lead to substantial savings, especially for applications with variable or unpredictable workloads. For example, a report by IDC noted that organizations using serverless architectures, such as AWS Lambda, experienced a 60% reduction in infrastructure costs. AWS Lambda's integration with other AWS services further enhances its capabilities. For instance, developers can use Amazon API Gateway to create RESTful APIs that trigger Lambda functions, enabling the building of fully serverless web applications. Additionally, AWS Lambda can be used in conjunction with Amazon S3 to automatically process data as it is uploaded to a bucket. This integration facilitates the creation of complex workflows and data processing pipelines without the need for server management. Security in AWS Lambda is managed through AWS Identity and Access Management roles and policies, which control access to AWS resources. Each Lambda function can be assigned a specific IAM role, ensuring that it has only the necessary permissions to perform its tasks. This principle of least privilege reduces the attack surface and enhances the overall security of the application. Moreover, AWS Lambda automatically patches the underlying infrastructure, relieving developers of the burden of maintaining and securing the server environment. The development and deployment of AWS Lambda functions can be streamlined using the serverless application model. SAM is an open-source framework that simplifies the definition and deployment of serverless applications. It uses a simplified syntax to describe the functions, APIs, and event sources, and integrates seamlessly with AWS CloudFormation for infrastructure as code. This approach allows developers to version control their infrastructure and deploy applications consistently across different environments. Testing and monitoring are crucial aspects of building reliable applications with AWS Lambda. AWS provides several tools to facilitate these processes. AWS X-Ray, for example, allows developers to trace requests as they travel through the application, providing insights into performance bottlenecks and errors. CloudWatch logs and CloudWatch metrics enable real-time monitoring of function executions, helping developers to identify and resolve issues quickly. Additionally, AWS provides local testing capabilities through SAM CLI, allowing developers to test their functions on their local machines before deploying them to the cloud. Despite its many advantages, AWS Lambda also presents some challenges. One of the main challenges is the cold start latency, which occurs when a function is invoked after being idle for some time. During a cold start, AWS Lambda needs to initialize a new execution environment, which can add a delay to the function's response time. Although AWS has made significant improvements in reducing cold start times, it remains a consideration for latency-sensitive applications. Another challenge is the stateless nature of AWS Lambda functions. Since each function invocation is isolated, maintaining state across invocations requires external storage solutions, such as Amazon DynamoDB or Amazon S3. This approach can complicate the application architecture and add latency due to the need for external data access. However, AWS provides managed services like AWS Step Functions, which help orchestrate multiple Lambda functions and manage state transitions, simplifying the development of complex workflows. The adoption of AWS Lambda is on the rise, driven by its promise of reduced operational overhead, cost savings, and scalability. According to a survey by the Cloud Native Computing Foundation, 41% of respondents reported using serverless technologies in production, with AWS Lambda being the most popular choice. This trend reflects a growing recognition of the benefits of serverless architecture and the efficiencies it can bring to modern application development. In conclusion, building applications with AWS Lambda offers numerous advantages, including automatic scaling, cost efficiency, and seamless integration with other AWS services. The serverless model simplifies the development process, allowing developers to focus on writing code rather than managing infrastructure. Despite challenges such as cold start latency and maintaining state, AWS Lambda's benefits make it a compelling choice for modern application development. By leveraging tools like AWS SAM and AWS monitoring services, developers can build, deploy, and maintain robust serverless applications that meet the demands of today's dynamic and fast-paced digital landscape. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.